If I ever broken a chair, I've broken plenty of chairs. I've broken plenty of toilets. We are recording, so that's 9 seconds in, Austin.
I literally have a page of all of
Yeah. I don't even understand the designs in those bathrooms where the toilet's mounted to the wall but doesn't go to the floor. Who thought of that? Who thought that was enough to bolt the thing to the wall?
Probably most engineers.
One time I broke a wall. Yeah, the toilet didn't even come off the wall. The wall fell forward and the toilet just became the pivot point. I'm not even kidding. This stuff happened. These they needed whoever gave that guy an engineering degree shouldn't have done that. A toilet needs to go all the way to the floor for structural. Yeah, I mean, it's just like 3D printing. You can't print that in the air. You need supports. Right, Jack? Jack's like, don't get me involved. All right, so we're starting our interpreter day, right? Now, remind me, for an object-oriented language, what must exist as the core component of our language before we can do anything else? An object, the idea of a generic object, right? So how do we represent a generic object in our language?
We have a function called Dave.
just Dave. Dave
Yeah.
is generic. You know, I have a brother named Dave.
Oh, there you go.
Yeah, so my brother is a generic human being?
No. I have a dad named Dave.
Because I was going to say, how do you know my brother so well? Where do we store our object? So there needs to be in existence, a generic object. Where do we put it? Just in our program? If we look at our class declaration here, and if we're creating for our own top level class, so we're creating a class called person, and we say that guy extends object. Where does object come from? Where are we going to go find that guy? What is that guy? Go ahead.
Would we kind of make him a base value in our environment?
Okay, so when we think about objects kind of live in our variable environment, right? That's maybe where we would put it. What belongs in our object type? So we kind of have two things to grapple with here. On one hand, we can say that we have the existence of a top-level object that must exist for the idea of an object-oriented language, right? Mm-hmm. But, and we've looked at, I think last class or something like that, we looked at the object type in Java, right? And we saw there's some stuff in there, right? Baseline stuff, things that we may or may not ever use. But in our language at this point, does object actually have to exist, or does the idea of object just have to exist? Could probably go either way, maybe, right? But can we come up with anything we should put into the object type at this point? Because object is a class, is it not? Does it have any fields? Does it have any methods? But might it?
Would it have a self field?
If you were inside object, it potentially could have a self or a this or a me, whatever we decided to refer to that as. So then from an implementation perspective, we can say, you know what? We're not sure what fields or what methods an object would have right now. But is it plausible that an object might have those in the future? Mm-hmm. Certainly plausible. So where do we store things that are part of our core language? In our environment, in our variable environment, let's say. How do we want to store that generic object? What is the generic object? What kind of animal is he in terms of our grammar here?
He's a class.
He's a class. But he's a class who extends what? Chicken or egg problem? It's like, well, hi, I'm a class name object and I extend myself.
Is this where we'd have to make a special class called object that doesn't extend anything? Yeah.
What's the advantage? How do we use the idea of extending objects when if we have a what's the best way of asking this? What's the purpose of extending objects?
Reuse of code.
Functionality.
Okay, so if I have a person object and we call a function on that person object and we don't find the function inside the person object, where do we look next? At his parent. So we just keep walking up the tree, right? How do we know we're at the top of the tree?
Can't go any further.
That is a perfect answer, right? Right? Whatever that means, right? Whenever we can't climb again, we're the designers of the language. We get to decide what that means. So we can create a class here called object and say that he extends whatever our black hole is or null or whatever it is. So a keyword. We can have it extend Dave. Okay, but if we do that, what we've done is we've disqualified ever having a class named Dave. Okay, so we're going to have some sort of reserved word. So we have this idea of reserved words or keywords in our languages, which effectively, as soon as we pick one of those, we've made that off limits. You can't have a variable name in Java called for or called if. Those are reserved words in the language because they have semantics before you came up with a name. All right, so what do we want to call that top level when we can't go any farther? Because we've agreed that even though we can't figure out what fields or we can't figure out what methods would go into an object right now, do we agree that it's plausible we might come up with something that would go in there later? We might want to have some common field. Maybe it's a memory address or something that applies to all objects. Okay? So we definitely want object to exist. You've mentioned that object should be a class declaration, that kind of thing. We do need to pick who he extends. So now we need to invent a keyword. A keyword that will be the special case for the I extend nobody. I can't go any farther. What do we want that to be? Dave? All right. We're the language designers here. It's fine. All right, so let's write this out first. So we have, where's my, here's my class, right? So this guy takes a name, a parent name, list of fields, list of methods. So I'm just going to define it down here. So we'll define object as being a class named, huh? Yeah, we're getting there. We got to do one thing at a time, V.
This is more important.
Well, it's not necessarily more important.
More important than itself.
All right, so we're defining an object. Now, we're actually going to probably put this guy in our environment right now, but just while I have the syntax somewhat fresh in my mind, it's becoming more and more stale as the seconds pass. We're going to call our constructor for class. The name of this guy is going to be object. His parent is Dave. Okay, we're sticking with this?
Yeah.
That means from this point forward, we have to remember that Dave is a reserved word. We cannot have a class named Dave. And Dave effectively means we can't go any farther. Okay. If we see Dave, don't even try. We're all cool with that? All right. So, and then we're going to have a list of fields. So,
If I'm Dave, return 9.
so nothing in there.
Mhm.
And then a list of methods. Nothing in there.
Yep.
That's our generic object. That's the guy that must exist in our language in order for everything else to work. Now, the question is, do we put him in our variable environment, or does he just is he just is?
Dave is.
What do you think?
Doesn't it always kind of have to exist?
Well, he exists right now, doesn't he?
Yeah, but like if you put it into the variable environment, isn't it just making that environment bigger for no reason?
Well, let's take that in two pieces. It's definitely making the environment bigger. I think it's up for grabs whether it's for no reason.
Well, I mean, one reason not to have it is you may never get to that point. So, I mean, why are you defining something? I mean, this is just kind of small amounts of time, but why define it if you're never going to use it? You might as well define it when you're going to get it inside the
I think we need to think ahead and decide how will generic objects work. So for instance, if I say define person, I'm going to put it in another variable for right now, just to give me a placeholder, to be a class. This got to be called person. Actually here, well, naming conventions. Objects are historically capital letters. So we have a class called person, and this guy extends object. And for right now, just so I don't have to come up with something, we have no fields or methods. When we go and try to execute something in the body of our solution related to the class that is person, I might be climbing the tree, right? So after I've searched inside of person for some field or some method that was referenced inside the body of the solution, I need to walk up the hierarchy. So I'm going to say, okay, I didn't look at I didn't find what I was looking for in person. Person, who is your parent? It's that guy. I'm going to search there. How do we find him? Where do we search for an object's parent? Where do we find that? I'll go down one more level. Define teacher to be a class called teacher, whose parent is person. And these guys are also empty husks. All right. So if I'm,
Teachers are empty husks.
I can't really argue. Sometimes the truth hurts. All right. So now we have 3 levels here, right? I can keep going, but 3 levels probably lets us see this. So if I'm trying to send a message to an instance of teacher, and that guy comes back as a, sorry, didn't find anything. Are we out of luck yet? Not out of luck yet. Where do we search next? Person. How do we know that?
It's the parent.
Teacher tells us that's who that guy is, right? So where did we find person so that we can create an instance? Does teacher have an instance of person inside of them? Does this variable named teacher have an instance of, actually we haven't created an instance yet, didn't we? Do we actually have an instance? Do we have an instance thing? Yeah, instance expression. So let me, Give me a moment. All right, so now I actually have an instance of teacher. So this is a teacher, so we're seeing our syntax for our language here, right? Even though we haven't put it into an interpreter yet. So we have a teacher. A teacher is going to be an instance expression, which is going to create an instance of the teacher class for me. And we're passing it no parameters to the constructor because we don't even have a constructor. Just roll with this for right now. We're not pretend like we're not dealing with fields and constructors and stuff yet. Dealing with the hierarchy aspect here. All right, so this guy right here is a teacher. He is an instance of the teacher class, just as if I create a second guy, this is another teacher. Now we have two instances of the teacher class. A teacher and another teacher. Make sense? Both of these guys are separate instances of teacher. Now, does a teacher have an instance of person within it? Does a teacher have an instance of person stored within it?
I don't think so. No. It is an instance of person.
Does another teacher have an instance of person stored within it? How many people think no? We have two people so far.
Well, not in the way that we're doing it right now.
Well, we haven't done anything yet.
Yeah, exactly.
How should we do it? How should we do it? So,
Well,
should a teacher, should another teacher have an instance of person stored within it? We haven't implemented anything yet, really, so the answer to anything would always be no for what we have now. Go ahead.
Can we create it on the fly? Do we have an option?
Yes, it's an option. Will we want to?
We just make it.
It kind of goes back to almost like, well, why make something if we're not going to use it? We'll just create it when we need it. So here, we'll fast forward a little bit. Could we create it on the fly? Yes. Should we create it on the fly? Unless you can make a good argument for it, probably not. And I'll swing back, if you want to think about it, I'll swing back around and ask why in a minute.
So when we did stuff in Android Studio last year, and we were, making our own extensions of classes, we were using Super to basically create an instance of the previous class before it. So it's
no, that's not
no.
true.
Okay.
It's
calling
almost true. Almost true what you just said. So you said we use Super to create an instance of the previous class. What did we actually use Super for? You're talking about when Super was in the very first line of our
use
class's
Super
constructor.
to do all the magic that needs to happen with the constructor.
So we use Super to call upon our parent's constructor as the first line of our constructor.
Mm-hmm. But it didn't actually make a separate parent.
Well, chicken or the egg. In order to call upon my parent's constructor, do I need to have an instance of my parent? So if we go back, we're going to go down this path here. So
We just make it look.
let's see if I have something I can steal in here. Here we go. Here's a car. So here at the beginning of car, I can go ahead and call upon my parent's constructor. I promise this line is already here, just invisible. If we don't write that line there, I'm actually kind of giving away the answer. If we decide to model ourselves like Java. A constructor, so our class car here, we've defined this guy as not extending anybody. So who does this guy actually extend? Extends object, right? That's what's actually there.
Mm-hmm.
All right? So that means Super is object, correct? And this guy right here says, I'm going to call my parent's constructor, which takes no arguments and does whatever magic it is to create the objectness of a car. Whatever it means to be a generic object. And then I'll make myself less generic by specifying what does it mean to be a car. So what you're referencing here is our call to our parent's constructor that we're allowed to do. We're allowed to ask our parent to do some initial setup, and then we differentiate ourselves from there. If you remember in Java, as well as most object-oriented languages, if we're going to have our parent do some initial setup, it's always the very first line, right? Because if I put this as a later line, it'll yell at me because we may have just undone something that we didn't necessarily know was happening inside of the parent's constructor. This is going to say it has to be the first line. Constructor call must be the first statement in a constructor. All right, so if we're going to leverage our parent's constructor, it has to come first, and then we can differentiate ourselves. We don't get to differentiate ourselves and then let our parent's constructor run amok. Make sense? All right, so getting back to Blaine's wrong answer, what's happening right here? What am I doing right there? Go ahead.
Getting all the fields and methods of objects and populating them with your own data.
Okay. I'm specifically calling, in this case, the constructor of object. Who is super?
Object.
Synonyms? It's the parent, it's object. Is it the class object?
Well, no, it's the method. It's the method inside the parent object.
I'm specifically asking, who is super? Go ahead.
The instance of the parent.
It's the instance of the parent. In this case, it would be an instance of object. We cannot reference a constructor or a method unless an instance first exists. Make sense? And if objects, when they're first created, if we're going to assume they always have constructors, if they are always built on top of their parent, whether we choose to do that ourselves or not. This is how object-oriented languages are built. There's this assumption that if you don't specify that this guy extends object, by the way, he does. And if you don't specify that you want the parent's constructor to be called first, by the way, it will. If I don't write any of that stuff, do we still have a variable named super?
Who's going
It's trying to do Netflix now.
Ninja. Wonder why.
I mean, it's still open.
Skynet. It's over now. 30 days free. I must have did like a software update because I thought we were already signed into this guy.
That's how they reel us in. 30-day free trials.
Yeah, and then you cancel and make another 30-day free trial with a different address.
All right, we're back.
Exactly.
You should go out for coffee.
Create a credit card.
Just like
All right, answer my question. I never said I extended object. I never called my parent's constructor. Do we still have a variable named super?
Yeah.
Java sure thinks we do. Does that mean that an object, in this case car, has an instance of his parent? Should a teacher have an instance of his parent stored within it? Probably, if we're modeling after Java. Now we get to decide, is there a good reason not to do that? Eric suggested that, well, should we do that if we're not going to use it? It's a reasonable enough question to at least ask, but the question is are we actually not going to use it?
I mean, I guess that depends how much we want to put in an object.
If I've written nothing there, have we actually not used my parent? Have we used the parent here?
Yes.
We have. This line happened. We built ourselves on top of the idea of our parent, a specific instance of our parent. If I am a teacher, if I'm this guy, a teacher is also an actual living, breathing person. And to be a living, breathing person, you have to be an instance of the person class. Therefore, for teacher to exist, person, an instance of person must exist. A teacher is a specialized version of a person, right? And in order for an instance of person to exist, an instance of object must exist, because person is a specialized version of object. Go ahead.
I'm afraid I'm gonna have to kind of use Java language to ask this question. But why would we want to specifically have it so an instance of teacher has within it an instance of person, and then that instance of person has an instance of object, but teacher probably also has an instance of object, right? So
No.
why no? Oh, okay. But why do that instead of just having super be a special case of self?
Are you actually saying two different things? So I think you asked the question, why can't teacher have both an instance of object and an instance of person in it? I think we could say that more accurately, a teacher has access to an instance of person, and it has access of an instance to an instance of object through its instance of person.
Okay, so we're not creating like a new instance in, or actually no, we would be for each instance of teacher would be creating an instance of person. So
Every instance of an object creates an instance of its parent until we get to an object whose parent is Dave. Then there's no more instances. We're at the top of the line there. Okay? If you look up and your parent is Dave written in graffiti, you're it. We're not searching anyplace else. So then my question still remains, is there an argument you can make for us to not generate an instance of the parent when we create an instance of a class? Go ahead.
I think the only time when you could make that argument is if that initial super call isn't gonna be there implicitly. So as long as that's there, you have to have an instance of the parent.
Should it be there?
Yeah, I guess it depends.
What's the goal of a programming language? What's the goal of our programming language here?
Just learn stuff in class.
That can't be the right answer. Otherwise, I can just give everybody A's and we can walk out of here. I get paid either way.
is it to bridge the gap between people and machine code?
That sounds pretty reasonable to me. Programming languages are a tool that lets us tell a computer what to do, right? And human beings are greedy. We want that tool to not just meet us halfway. We want it to meet us 99.9% of the way on our side. So we want to talk to that computer like I boss V around. Go get my refill, blah, 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 right?
Wait, you're saying V isn't a computer?
No, unfortunately. I would get less feedback. It would be much more digital in nature. I'm getting a lot of analog signals, man. Okay, so, the idea of a programming language is to allow us to conveniently use the way we solve problems as people, That's what we are. We're expert problem solvers, and have that translate as conveniently as possible to tell a computer what to do. Right? So if we are trying to imagine, so one thing we don't want to, we might be inclined to say, well, we don't want to just copy Java, but we also don't want to necessarily say that Java didn't do some things right. Make sense? So don't not do something just because Java does something. We've already sort of done that by saying, look, it's not called object, it's called Dave. Fine. That's okay. We'll just say that's okay. It's weird, but it's okay. But if we're thinking about the way human beings solve problems in real life and how we conceive of things, okay, and we look at everything here. Am I a teacher? You can argue, right? Okay. Let's say yes. Okay. Now, am I also a person?
Hopefully.
Yeah. The jury's out. Okay. But the idea is that these are truths. So we'll go to a normal human. We'll go to like Blaine, right? Okay. And Blaine's also a teacher. He helps a lot of people, tutors people. Okay. So we'll say Blaine's a teacher. He's also a human. Now, he's also a couple other things. Blaine sings. You play some sports too, right? What sports do you play? Badminton. He plays badminton.
Yes, very
Okay.
professionally.
Okay. Blaine is all of these things, but he has a core thing where he's a human, right? And then even before that, is Blaine a thing? Is he a physical piece of matter in this world? He's a thing, right? Okay, so Blaine is a thing who's also a human, who's also a student, who's also a teacher. He's all of those things, right? At every single one of those levels, it's really one of those. So he has these specializations. You know, so his badminton-ness.
Badminton-tea. Yes, that's what it's called on the court.
And that's what we. That's how we use it. You know, I don't know. Is it even called a court?
Well, I'm using layman terms.
I'm just dumbing it down for you. Badminton is a serious thing.
I don't know if that's ontologically correct. We're only focusing on the material cause of Blaine. We really need to look at the efficient cause as well.
So the idea is that he has that specialty that makes him a little bit different than maybe V might be, who has all sorts of things in common with Blaine, but she has this other specialty, right? Or these other 5 specialties that define who she is, more fully define who she is. But both of them are humans. One of them is female, one of them is male, right? So that differentiates them. And then they start going into further specializations in terms of who they are as you know, badminton player. What's V's specialty?
Cricket wrangler.
What?
Cricket wrangler.
Cricket wrangler. Actually, that is accurate. Cricket wrangler. Yeah, the Ann Arbor folks are probably wondering about that one. Last semester, V just brought me a bucket of crickets to class as a present. Live crickets, hopping.
She's Vietnamese.
Shut up.
Okay. So really, she brought me lunch.
It's in the beer bottle too. Beer wrapping.
All right, so this is how we solve problems as human beings, right? That's how we conceive of things. What I just did to describe Blaine and describe V, that's not like this foreign alien language to us. That's how we think about people. Do we have a reason to think about people differently? Do we? Can we find a better way of organizing our thoughts around, you know, Blaine is a badminton, has a specialization, who's also a teacher, who's also a student, who's also a human, who's also a thing. We can add layers in there, but that's gives you the example, right? Do we have a reason to differentiate, to think about that differently? Or does that match up to how we already think about the world? I'm asking the question. It's a legitimate question to ask. Are we happy with that way of conceiving of objects in our language, which has a goal of allowing us to talk to a computer in a way that's as close to the way we already think as possible? Or can we come up with a better way, or should we come up with a better way to conceive of objects in our language? I mean, does Blaine only become, show his humanity on demand? Or is he a human all the time? Did he get to pick and choose whether he's going to play the role of a human today? Or when he rolled out of bed, it's like, man, I hate it on Wednesdays when Blaine just chooses to just be badminton. It is, that throws me for a loop every week.
I know the true answer to this, but I'm also not allowed to tell you because of that fact.
But the reality is, that's how Blaine's a human all the time, right? Blaine's a person all the time. Blaine's a thing all the time. He's a student all the time. He's a teacher all the time. Now, he might not be using those abilities all the time, but he is those things all the time. So are we happy with the way that Java organizes its objects? Is it good enough? Or do we want to enhance it? And if so, how? What do you think? Go ahead.
Just kind of a general question. So when we call super, I guess in the case of our language, what would be the difference of creating an instance at that moment of calling super versus creating an instance before? So that way, if we never call super, then we wouldn't have to worry about getting a parent. But if we called super, then we'd create an instance in that moment.
So if the parent has to, we're going to use a Dungeons and Dragons example to answer your question. All right, so we have a generic person, and one of these things is armor class. All right, so maybe a generic person has an armor class of 3 to 8. All right, so when we generate that person, we give him an armor class of 3 to 8. That's how tough a generic person is. All right, now we have a warrior. When a warrior is born, he's going to have his instance of person generated then, which will then give him an armor class, which he might then choose to change. He might decide whatever my armor class is. Remember that my call to the parents constructor happens first. So my armor class is whatever it currently is plus 3, for example. So a warrior cannot come into existence not creating his version of super, not creating his personness, because he will then not have the armor class that he is going to then modify. Go ahead.
Sure, but when that gets called, it's already going to be searching up the list. So if it doesn't find it within that object, it can call super and look in the next object, and then call super and look in the next object.
I gotcha. So you're suggesting we could do this on demand, where if we didn't automatically call super as the first line of the constructor for warrior, and then all of a sudden we are trying to update this variable called AC that we didn't specifically define as one of our fields. And now we go on this wild goose chase and we say, okay, well, I can't find it here. I need to look up one level. And at that point, since that exact point is when we need to start searching, that's when we might generate our superness, right? Okay, let's say that's fair enough. So let me see if I can give you then an example of. Okay, got it. So we're going to say name. Let's just say our parent's constructor takes a single parameter in, and that's name. And a warrior would then have access to that, that name. Now, the warrior then also has a method called do damage, something like that. And this guy might say that Mike hits for 3 damage or something like that. All right, that's what we want the output to be there. So this output is built in terms of the name of this warrior, when the name of the warrior is actually held inside of person. Now, if we're down here, our first time that we try to call a function called do damage, maybe do damage is a local function of warrior, but he's referencing a variable called name. So here, we'll write this kind of Java-esque. Name concatenated with that. When we get to this variable called name, we're going to look locally here at warrior, not find it. At that point in time, you would suggest we need to generate our super. The problem is since we have already passed our constructor for building our warrior, where presumably the name of that warrior was passed in, we now have lost our ability to generate an instance of person because we don't have the necessary, we've lost access to Mike. We don't have Mike's name anymore because presumably it was passed into the constructor for warrior, and we chose not to create our instance of person then because we didn't actually use it then. We were just using it to set some field up. But later on, we needed access to that field. Could be an hour later. We got into some fight out in the wilderness, and we wanted our output to use our name as a parameter. And because we chose not to create that instance an hour ago, using the name that was presumably passed into the constructor for warrior to create the name for person, we now have lost the ability to do that. That makes some sense? So we can still do it, right? We can still say, well, what's our trade-off? Let's go that route. Why might we want to not create the super? Go ahead.
Would that interfere with our armor class in this case? So say you make the armor class, a little bit after type of thing, but then when we go on for a journey, you might have to get our name later on. Are we going to have to call super again, and then would it reset the armor class to being regular 3 to 8?
Well, no, because in the way Java works, for example, and C# works, all of our object-oriented languages work, is the parent is always created at first, so the armor class and the name get set once. And then from that point forward, they're never reborn. We can modify them from that point forward, but they don't get set back. We only call the constructor one time. Is that what you're asking? Do you know what you're asking?
I lost it. It was less about how Java does stuff and how we're talking about maybe or maybe not doing our thing.
Okay, so really these are two separate examples. So I gave the example here of if we're going to define armor class in terms of a preset armor class in the constructor for warrior, at that point in time, Eric's potential solution would work. He's saying, look, at that point, we're relying on something we can't find, so we'll go ahead and create our instance of super. That's fine. On demand creation of super. We're okay as long as that's still inside of our constructor. So then I gave a secondary example where I said, okay, now we're past our constructor. Our constructor for warrior has finished. This guy doesn't exist. This guy doesn't exist. This guy doesn't exist. We've lost our ability to set the name because we didn't create the constructor. We didn't call the constructor up in our constructor for warrior. Now we call our warrior's do damage method that has finally decided to use one of the abilities, one of the fields of the parent. So at that point in time, Eric's solution would say, I haven't created my parent yet, but now you're asking me to utilize my parent, so I'll go ahead on demand, create an instance of my parent.
But we don't know the name.
We don't have the name anymore.
Okay.
Yeah, we lost access to that information because that's the point. When Blaine was born, he was already a badminton player, a teacher, all these things, let's say. Okay. He was a thing. Do we say things have names? Not necessarily. Maybe not all things have names, but all people have names, right? So it's Blaine's peopleness that dictates he should have a name. Okay? The fact that he is a male is not the aspect of him that dictates that he should have a name. Both males and females have names because people have names, right? But if we didn't create the peopleness of Blaine and of V, they wouldn't have their name. But the first time somebody goes and calls Blaine by his name, if he hadn't pre-generated, pre-instantiated his peopleness, he now no longer has a name, which probably wouldn't actually change my life substantially, I'm thinking. Go ahead.
So, yeah, I get just kind of double check reaffirming, like if becoming a great badminton player, I didn't have to make a new name. That doesn't make sense.
I know what you're driving at.
I haven't been talking
Like-
since you started babbling.
No. I was having great thoughts while you were babbling.
Oh, I see.
But when I become a badminton player, I don't get renamed. But if I mean, sure, I could get a nickname, but that'd be something separate. My name wouldn't be reblamed. Yes. I'm not saying that right. I think I understand now.
You wouldn't
That's what I'm
create,
trying to say.
you wouldn't update your name. Otherwise, maybe you give yourself a title, Blaine the Badminton Champion. So you could enhance your name to your badminton-ness. You know, if you later became a knight or knighted, then you'd be Sir Blaine. But your actual name is Blaine.
Yes. I guess what I'm getting at is if I became a badminton player, when I went up to V and she doesn't know me as a badminton player, she'd still call me Blaine. It just is like other people playing badminton would call me Blaine also. So my name Blaine isn't keyed into just being a badminton player. It's that I'm a person.
Okay. I think that's accurate.
Yeah. No, I'm just trying to say I get it.
Okay, well, good. Everybody else get it? Okay, so we decided that Eric's wrong. That on-demand creation of super, while, I know we're out of time, but I asked the question a few minutes ago, what's the advantage? What you were trying to do is maybe save some space, save some time. Let's not create a whole object if we may never use it.
Mm-hmm.
And that makes some sense, but once we went down that path, we thought we're kind of giving something up there. And it's probably not worth it. So we probably need to create these things. Make sense? All right. Homework assignment for Monday. We're going to create your environment. You can create your environment however you want. You can model it off our old environment, or you can have a new invention for your environment. But it should have your starting point for your object. We have an object. You just need to throw that into your environment. And then start our interpreter for a solution. And let's give it just the ability, the creation of a class. Not an instance of a class, but a class itself as part of the expressions of our language. Go ahead.
Just as far as environments and classes and stuff, should we have two environments to save time? One environment that just has the kind of class templates, and then another environment that stores all our variables and instances?
That's up to you at this point.
Okay.
Yeah, I don't know how I'll choose to do it in class. I haven't thought about it, but it's dealer's choice.
Okay.
All right. I'll put the current version of the code up, even though we only put a couple of things in there, but it gives you kind of some of our syntax as a starting point. But for next class, you're going to have just the very first couple of pieces of our interpreter, but you'll have to have a fully functional environment. So, you know, you should be able to look things up in our environment. That is variable resolution. So give me a working environment and the start of our interpreter. And shove the object into the environment. And you should be able to test it by saying, hey, give me the guy named object. Or whatever you want to name him. Cool? All right, I'll see everybody on Monday.